Hello, I bought this little laser module recently. I thought I might slap it on my CNC machine and see if I can cut some things with it. Mainly I'm just thinking to cut cardboard and maybe plywood as well would be nice. That's about it. Not going to be doing any engraving or drawing pictures or anything like that. So it's going to be pretty simple stuff. And the type of the laser is that. I'm not really sure how you're supposed to say that. It's 40 watts. I think it's supposed to be 6 watts, like actual output power. It's quite small, decently heavy for what it is. Looks like this case here is, well, it's a bit hard to see in there, but it's not really square at all. It's just the central part is circular, and all around the outside is just heat sinking, and that's about it. On top it has a little bit of a circuit board thingy there, and this one runs on 12 volts, and it also takes a PWM input to control how much percentage of the laser output it should be using. And on this end we have a little shroud for the air to go through, for the air assist. So you would put some air coming in through the side, and it would pump out the front there just to keep the smoke out of the way. And then we've got this little sort of eye shield, or whatever you call it, like that. So pretty simple, about 100 USD I paid for that. We'll see how it goes. A few other things we got in the box were just some connectors which have plugs for that plug that we saw on there. Oh, there's a switch on here too, which is quite convenient. So this little button is a switch. You can turn it off and on like that. Just a few little connecty bits, Allen key, and something to take the lens off, I think that is. And then there was a little block of aluminium which you would use to set the height. So you'd put that on top of what you're going to be cutting, and then you would lower the laser down so that this the front this front edge touches on it like that, and that would be the right height. And then there's some glasses, and what's this? I'm not really sure what that is. Is that a lens or something? I don't know. Anyways, so that's all there was in the box. First job though is to figure out a way to stick it on here. I'm thinking to put it right on the front. So I have designed a little plate that can go onto here. I'm going to have to drill and tap some holes in here, but I think that's okay because right out on this corner there's nothing in there. It's just it's circular, right? So on this corner all there is just a bit of heat sinking. It's not like I'm going to be drilling into the motor itself. And then on the back of this there's some nice screw holes which we can use to mount it on there, and well, let me get that started. That's what this plate here is going to become. My ears! Ouch! Is it stuck down properly? Need my earplug. I mean, what do you call it? Earmuffs. That sounds awful. It's also the wrong job. Let's try the actual job. Okay, so those 4 holes at the bottom are going to go onto the holes on that, like that. And then this pocket on the back is to just raise it a little bit clear of this plate on the front of this. Nice. Okay, so that's mounted on there now, and as you can see, it's going to end up slightly below where the collet is. So I don't have to really take the collet off, but I probably will have to take the end mill out. Whatever end mill is in there is going to be a little bit lower than where the bottom of this laser thing is. Now, there was no user manual included with this, but there's a decent amount of information on the AliExpress page. And looking at what it says about this PWM signal, 5, what? It's a little bit strange. 5 to 12 volts, I'm assuming, is the voltage that it needs. I'm not sure why it says 0 there. And then it says, again, 0 to 1 kilohertz, which is also a bit weird, because does that mean that a 2 hertz pulse would be sufficient? I don't think so. But anyway, the fact that there's an upper limit on that, the 1 kilohertz, is a little bit inconvenient, because the default pulse width, or the pulse frequency from the Weenie PRU is going to be 10 kilohertz. That's the one that's for the spindle output, which is what I'm planning to use. So the fact that it says up to 1 kilohertz makes me a little bit worried that I couldn't use the 10 kilohertz pulse, but I'm also kind of thinking it might work. So what I'm going to do is use my I/O mixer, and I'm going to just set up a little test thing like this. This is the whole program or configuration. It's just an analog input, which is a potentiometer, and the output is a duty cycle PWM pulse on pins 18 and 36 respectively. And over here we can set the frequency for the duty cycle PWM output pulse, and I've set that to 1 kilohertz at the moment, and have that set up here. Unfortunately, this the I/O mixer only does 3.3 volt signals, so I'm using a little level shifter to get 5 volt signal there, and my input is the potentiometer, and the output is just going to the oscilloscope here at the moment. So you can see when I turn the potentiometer, I'm getting a pulse that goes from nothing up to well, I didn't calibrate anything, so this particular potentiometer only gets to about 98%, but that's okay for this little test. And you can see that that is 1 kilohertz pulse. So I will try that first, just to make sure that the laser is working and everything is okay, like I didn't get a dud or anything. So I'll try that with the settings that it recommends, but we can also pretty easily just change this to a 10 kilohertz pulse here by, if I could find my mouse, we could just go, whoops, sorry for the shakiness. Just go like that and then do upload, and then if we come back over here, we'll see a whole lot more pulses, and we'll see that that is now 10 kilohertz. Put the camera back in my hand that doesn't shake so much, and we can see we've basically got the same thing, but it's at 10 kilohertz. So I will try that afterwards, and hopefully that will still work. If not, I will have to fiddle around with the firmware on the Weenie PRU a little bit, but I really don't want to have to do that. Okay, I got all that stuff out here now. I'm just going to power this from a 3S LiPo. It's at about 11 volts at the moment, so should be alright for just a quick little test. And I'll put the camera over this side so you can see what's going on a little bit better. Plug in the battery. Alright, fan is spinning. That's a good start. Oh, it looks like the fan is just permanently on. Alright, and when I push the button up on the top of this, the little blue light shows up on the circuit board. Alright, now let me fiddle with the potentiometer here a little bit. Whoop. Oh, okay. I see something there. It looks orange in my... I smell a little bit of burning wood, so... Okay, that seems to work. This works great, actually. Let's crank it up a bit more. Okay, so there's a very fine little mark there. It works. Now we have to try with the 10 kilohertz pulse, because that might not work. Okay, now trying with the 10 kilohertz pulse. See if it still works. Ah, it does. Looks good too. Let's drive it around a little bit again. So that's good to know. The 10 kilohertz pulse works just as well as the 1 kilohertz pulse. And here's the result of that. I'm actually quite surprised at how thin these lines are. Okay, I have everything wired up now. It's a little bit rough, but this wire goes along with the spindle cable over to there, and then here it splits into a bit that goes down into the main control box and a bit that goes up to this 12 volt power thingy, which is running my lights up there. So in order to turn the laser on, I have to turn the lights on as well, but that's alright. And I just did a little test program here to check that the spindle is actually controlling it, or what would normally be the spindle, M3 6000. That would normally turn the spindle on to 6000 RPM, but what it's going to do here is it's going to turn the laser on to approximately 10%, and then it's just going to wait 1 second, and then it's going to turn the laser off. Now let's draw a little square. Just a hand-drawn square. Okay, well everything seems to be working okay. I managed to draw some little squares there, and with about 20% power I was able to cut through this slightly yellow piece of paper with no trouble at all. This is at 1000 millimeters per minute. Whoa, that's not so great. Okay, I wrote a little program to play around with. Rather crude. It's just using some G-code like that, variables in a loop, or 2 while loops like that. And just fiddling around with the paper like that. I tried this foam too, but that didn't go very well. I mean, it's clearly cutting through, but it sort of sticks to the side again, and on the back it's all blown out. And the pieces that come out of it are really messy too. This is not something that I was planning to do. I just saw this foam sitting there and I thought I'd give it a try. But anyway, so the paper is working out pretty nice, but I'm already noticing that it's cutting more at the corners because it slows down to, it doesn't quite stop at the corner, but it comes to almost a stop. I'm getting the feeling that the speed is more influential than the power sometimes. So that top row is 400 millimeters per minute. It's kind of slow, but it's doing a good job. What's interesting is that there's hardly any difference between 50% power there and 100% power there. Well, I've been doing a bunch of testing like this, and I was kind of getting puzzled about why the difference in power wasn't changing gradually. As you can see there, it suddenly changes very quickly between one row and the next. And then I realized that I'm using the wrong mapping for I'm using the one for the spindle speed. Well, I'm not now, I've fixed it, but I was. So I set up this other one, which is a mapping especially for the laser, so it goes maps 0 to 100 into the 0 to 65535. So when X is 0, Y is 0, and when X is 100, Y is 65535. And then put that in a file called laser.hal, and then in my ini file I'm going to have to comment out the one that I was using for the spindle, which had a similar mapping, but it was different because it was trying to target a certain RPM speed of the spindle. And then I'm going to have to include that one called laser.hal instead. So I'll just have to switch this when I want to change between using the spindle and the laser. Okay, I finally got this figured out. That's a little bit more like what we would expect to see, right? Sort of a diagonal gradual sort of line like that. And then on the back, almost nothing in this corner where it was 10% power. That's 100% power up in that corner, and it should be smoothly varying. So finally got that sorted out. Unfortunately though, it's not cutting through this cardboard as quick as I would have hoped. Even at 100% power, it looks like we can't go much more than about 600 millimeters per minute. I would have liked to go a bit faster because I might be finding myself doing a lot of this at some point in the future, so it's a little bit of a bummer, but I mean, it still works. I'm just trying some plywood now. This is 3mm, and it looks like we need to go significantly slower and also do 2 passes, but it is just making it through there. So I'll do a little bit more experimentation, and I have some other plywood as well. This is about 3mm. Well, I've been playing around with this piece of plywood, getting some reasonable results actually. Need to do 2 passes, of course, and it still seems to be a little bit random as to what exactly is going to happen. See, this is 200mm per minute, so it's going half the speed of the one above, but it's actually cutting through there at 70%, 80%, whereas this one didn't. So I guess there's just some random inclusions in the panel underneath it or whatever, but yeah, it seems to be reliable at 100% at 100mm per minute anyway. And I plugged this air assist thing into my compressor, and I'm just holding the lever on that to make it go. And the compressor has a regulator on it, so I can make just a nice gentle breeze instead of like a gushing torrent of air. Seems to be good enough. And then I was just going to finish for the night, but I thought I'll try this piece of plywood as well. I didn't think it would go so well because it's paler, and I thought that darker things would absorb the light a little bit better and cut more easily. But wouldn't you know it, look at this one. 1 pass, so it's the same settings as I was using here. This is 2 passes with air assist. I thought the air assist might help. Didn't really seem to do much. If anything, maybe a little bit better perhaps. And anyway, so this is exactly the same settings, and also air assist on the one at the bottom, but it cuts through in 1 pass. Same thickness of plywood, 3mm, or 1/8 inch actually. This is the stuff that you might see quite commonly. We have this at Bunnings or Mitre 10 or whatever in New Zealand, but it actually comes from USA, so a lot of you Americans might recognise that one. But yeah, that's good. So that cuts really easily. I tried raising this plywood up a bit like that, and these ones here just fell straight out without having to even touch them. So that should give you an idea of what you can do with one of these things. Not too bad. Quite different to the other plywood. Not exactly sure why, but I guess it's the interior layer is quite different, I suppose. Just going back to the cardboard again with the elevated position and the air assist to see if it makes any difference. Doesn't really seem to, so that bit there is the same settings as that bit there. Same result, or maybe a little bit better cut through here, but not much. The only difference the air assist really seems to make so far, I've noticed, is that the reverse side of the thing, oh sorry, not air assist, the elevation, oh and the air assist maybe, is that the reverse side of it's going to be a lot cleaner. So this is when the plywood was sitting directly on the MDF, this is the bottom of it, and then this is when it was elevated up on these blocks, and there's really no dirty marks on the back here at all compared to that one. So I guess that's nice, but it's probably a little bit, I don't know, is it more likely to start a fire if it's like flat on the MDF like that? I think it would be, right, rather than elevated like this. So after doing a bunch of tests like this to figure out suitable laser power and speed to cut through this cardboard, it was time to try making some boxes. And the reason I want to make boxes is because I'm sending out these IO mixer boards sometimes, and I've been doing that by printing out these prepaid like packing slip things and making a box that's just a little bit bigger than that could fit about 3 of these in. That's the plan. And until now I've been doing that by placing this paper template onto some cardboard and then tracing around it with a pen and then cutting that out by hand. It gets the job done, but it's a bit crude and takes quite a while. It's like a fair bit of manual work to do that. And this cardboard that I was using, I don't really like this too much. I got this from Office, what's it called? Warehouse Stationery, which is like a office supplies store here. It's quite thick. It's about 4mm thick. You can even see daylight through those flutes quite easily there. And it's kind of feels quite soft, and it was actually part of a larger box that you buy as a flat pack box that you can tape together to, if you were going to move house or something. So it's got creases like that crease that I just put in there. There's a whole bunch of creases all through it that you have to avoid if you're trying to make your own box, which is not very suitable. I just didn't really like it that much. And I have a whole bunch of boxes sitting near my fireplace ready to be burned eventually. And some of them have this, it's about 2mm thick cardboard, which is really quite nice for a smaller box. And I was trying to find something like this, and I was doing lots and lots of Google searches, but I couldn't really find anything that was reasonably priced, and it wasn't, small pieces, and it was somewhere that I'd be able to go and pick it up easily, and it wasn't this like soft 4mm thick one. But it wasn't having much luck until I turned this box over. I must have walked past this hundreds of times and not noticed this, but if I turn it over here, there's a company name that says Compact, and I thought, well, that must be something overseas, so that's not going to help me much. But I googled that name anyway, and lo and behold, that is a place in Auckland, or one of their outlets is in Auckland. So I don't know what they're doing with search engine optimization, because I had to actually Google that company's name to find them. All of my searches for cardboard or sheet cardboard or sheet board or all those kind of packing materials and stuff like that just wasn't giving me anything. So that's kind of weird. But anyway, this company has this board that I've been using for my tests, this one here. It's white on one side, which is kind of nice, and it's R flute, which is the same as these two boxes that I'd have as my target to shoot for doing the same thing as. It's nice and cheap, and the sheets that they sell it in are just the right size to fit in my car. So they're nice and big, but they're not so big that I need to pester the people at the factory to cut them for me before I can put them in my car and bring them home. So having located some sources of this cardboard, I thought I'd try for something a bit fancy like this, since I now have a laser cutter, so I have a accurate and repeatable and relatively not very labor intensive way of cutting card. Thought I'd try for something like this. It's a little bit fancy though, because you need to fold that edge down into little tabs at the bottom, and then this folds over the top, and the bit at the front folds into a cavity there. And it was going okay. These are my attempts. It was going all right. I probably could have persisted and made something that was going to be usable, but I just wasn't feeling it, and I don't think it lends itself very well to making boxes that are just very shallow or not very tall. So this is the total height of my box is going to be a little bit more than that, so about that much. So this overhang is a bit too much there, and overall it was just sort of feeling a little bit complicated and not very bang for buck as far as time and effort was going. Also, there's a whole lot of folds that you need to do, and a lot of them are not collinear. It might at first seem like this fold and this fold are in the same line. Actually they are in this one, because this is wrong, but in one of my other ones, I think one of these other ones is a bit better. But anyway, you can't do all these folds along here at the same time. You have to do them separately, and it's easy to screw up the folds too. Like, you've got to remember which side of this tab cutout needs to have the fold on it and stuff. Yeah, so I just wasn't really feeling it with that design, and I thought, what if I go back to my simpler design like that, which is this, and this is a whole lot easier to fold and to design and to cut and to assemble. Everything is easier, and I can actually fit 25 of these onto one of the 1600 by 1200 sheets that I've bought, as opposed to 20 if I'm doing that design, because this bit here needs to be repeated twice because it folds over like that. So just that little difference means I can use the boards much better. The downside to this design though is it needs tape to hold it together. So this design, if you fold it up properly, obviously you would tape it as well, but it holds itself closed with no tape, which is really nice. But anyway, with a bit of tape, so this is what I'm going to go with. It's a little bit more plain looking, but like I say, a lot easier to design. Doesn't look too bad. I mean, it's just something to put a circuit board in, and somebody's going to just throw it away anyway. So that should be good enough. And before you know it, I had made a whole bunch of those ready to use. So that's what we're going to do. Okay, so I think this is going to work out pretty well. It's a little bit slower than I had hoped for, but the nice thing about it is that I don't have to do any manual work like I did before to make each box, and I can pretty easily get two at a time like this. The machine could do almost three at a time, but I've got this vise here which is kind of in the way and makes things a little bit awkward. So I'm just going to settle for two at a time, and I can line it up nicely by using the vise. Okay, so it is good for something. I can clamp this in here, which I know now to be straight with the machine, and then just put a block of wood in here to get a little bit of clearance, put the cardboard up there, take the block of wood away, push the button, do something else for a couple of minutes, and then I've got two boxes ready to fold. So the folding is still a little bit tedious. The way I've been doing that is by putting the cardboard under here on this edge and then using this piece of wood to like fold it up like that. And yeah, that is getting a bit tiresome already, so I might have to make a little break. Would it be called a break, I guess, this kind of thing? Wow. Man, this does a great job. "56 minutes this one took, but looks like it turned out pretty nice. I was able to push the speed up a little bit and still cut through. So this was at 106 millimeters per minute and 100% power, just one pass. Looks great. I think quite a bit of the smoke that comes off this is actually coming off the MDF on the bottom. I noticed when I had the cardboard on here before and I accidentally ran outside the cardboard so that it was just cutting the MDF, so like that. Yeah, this cut here was supposed to be on the cardboard, but this just went straight into the MDF, and man, the smoke was pouring out of here. And I checked with the blade of the knife here, and it only cut about 1 millimeter in, and that was 90% power, so that's probably what you could expect for that. Although that was 550 millimeters per minute, so a little bit on the slow side. I'm not really planning to cut MDF though, so I don't know if I'll bother doing many experiments with that to test the speeds or anything. Well, that's about all I have for now. Just before I finish though, I wanted to show you how I've been generating the G code for this. I wanted something that I could use on Linux and that wasn't going to cost me too much, and that would let me turn the laser on and off. And I came across this thing called DXF to G code, and this is going to be just fine for me because all I'm doing is taking a DXF file and I'm using the lines in the DXF to either cut right through the material or etch a little bit on top of it. I'm not going to be doing any photo engraving or whatever they call it. I've seen people doing that. Looks kind of interesting, but I'm not planning to do that. So just turning a plain old DXF bunch of lines into G code is going to be fine. But what's really nice about this program is it has a very easy to set up post-processor configuration, unlike Fusion 360, which is a huge pain in the ass. This one is easy, and all you do is for each one of these kind of events that happen during the job, you just put in what kind of G code you want to issue for that job. So for a tool change, you can see I've deleted that because I don't want anything. Likewise, positioning for Z plane, I've deleted that, and linear feed move for Z plane. I don't want it to do anything in the Z plane, basically. So this lets me just make sure the machine is never going to move in Z ever for this job. And then the way it works is you put in, say, for example, for a feed rate change, we want F, and then this percent feed is going to be a value that will be replaced by whatever the feed rate is at that point in the job. And then percent NL is a new line. And so that's fine. But importantly, if you look down the bottom here, we've got placed in front of any shape and then placed after any shape. The things that it's calling a shape is basically, if you were using an end mill, it's where the end mill goes down into the material to start cutting, and then when it finishes, that's what it's calling after shape. So for the case of this tiger drawing, each one of these things here is a shape. So I'm using that to issue an M3, which is going to turn the spindle on, or in my case it's going to turn the laser on, and M5 after the shape to turn the laser off. And for the M3, when we're turning it on, normally you would issue S, and then this percent value would be spindle speed, or just speed, or something like that. But as you can see, I've replaced that with percent tool number, which is a little bit strange. But if we look at my tool table, which is in another configuration section here, in my tools table I have set up a bunch of tools that rather curiously all have a diameter and speed and start radius of 0, but the names are significant. So I've got 10, 50, etc. up to 100. And then, for example, when we select this shape here, we can see over there, you know, what we're going to do with this shape. And here I can select the tool number to be, in this case, 90, for example. So this is going to be my laser power, 90%. This only works if your laser power can be set in integer numbers. So if your G code was expecting that your laser power was a number between 0 and 1, like 0.75 or something, this approach is not going to work. But my laser power is being set as a value between 0 and 100, so integer values will be just fine. So anyway, the tool that I select is going to be my laser power, and then for my feed rate XY, this is just as you would expect, just the normal feed rate there. So that happens to be 100, and I think I had it on 100. So this is what I was doing before. 100% laser power, 100 millimeters per minute. That's how I was cutting through that plywood to make the tiger. So that is a very convenient way to set it up, and it's been working great for me. You do also have to set all these values to 0 as well, which is a little bit odd. And the only slight inconvenience with this method is that when you do export shapes, and then you try and let's export there, it says error, Z in feed depth is null, and that's because this is the step down depth apparently. I don't know what they call it in feed. I've never heard that term before. I had to actually Google what the heck this is supposed to mean. But this is step down, and obviously it doesn't make sense if you're using an end mill to cut something if the step down depth is 0, so it's saying that's wrong. Then you have to click to make this dialog go away for every single in this case 72, all 72 of these paths. I have to click this 72 times. So if I could just find a way to get around that would be nice, but otherwise this little software package has been working great for me, so I think I'm just going to keep using it. Anyway, that's all for this video. Thanks for watching. See you later.